Our next presentation is the Multi-Party Research Initiative, MPRI, that Jordan forecast. Dr. Ken Lee is going to be presenting a scientific research network under Canada's Ocean Protection Plan to support decision-making in oil spill response. Dr. Lee is a National Senior Advisor for Oil Spill Response Preparedness, Oil Spill Research Preparedness and Response for Fisheries and Oceans in Canada, and Science Lead for the MultiPartner Research Initiative under Canada's Ocean Protection Plan. MPRI aims to promote collaborative research at the national and international level between academia, government, and private sector to advance oil spill response measures and science-based decision-making during oil spill response operations. I've been looking forward to your presentation. You guys are doing a lot of really terrific work up there. So with that, thank you for being here, Dr. Lee, and take it away.
Great, thank you, Greg. It's not only good work up here, we're actually working with our partners in the States, and I think we have just as much of an investment in the US as we do in Canada right now. Anyway, I'd like to talk about a research program in Canada called the MultiPartner Research Initiative, and it's really to provide science for decision-making when there are spills. So the MultiPartner Research Initiative is part of a program under Canada's Oceans Protection Plan. And this program is unique in the fact that what we wanted to do was to establish an integrated global research network to advance oil spill research in Canada to enhance Canada's level of preparedness and response capability. But one of the things we realized is that oil spills really aren't a Canadian issue, it's a global issue. And we had a report that I chaired in 2015 under the Royal Society of Canada on the behavior and environmental impacts of crude oil released in aqueous environments. And there was also a Transport Canada tanker safety expert panel report the same year. And what these reports noted was that when spills occur, we really have to make decisions, and we need science to bring those decisions to the table very quickly. And one of the things we identified under the Royal Society of Canada report was we need better networking to bring the community together. So the unique thing about this program is that it's one of numerous programs under the Canadian federal government, but this program is focused on funding research within Canada with academia, industry, as well as international partners, including other government agencies, as you heard today, in other countries. And the focus of this program is really how do we expand the toolbox for oil spill response within Canada. It's called the MultiPartner Research Initiative because it really includes a number of federal agencies in Canada. It's led by Fisheries and Oceans Canada. It also has collaboration with Canadian Coast Guard, Environment Climate Change Canada, Natural Resources Canada, and Transport Canada. To date, we've funded about $45 million. This money has been distributed across approximately 80 research sites in 12 countries. MPRI is funding around 260 researchers, and this includes 26 postdoctoral fellows and 58 graduate students. We have about 40 projects that are ongoing and completed to date. So when we're talking about what we're going to focus on with the MPRI research program, the Royal Society of Canada report identified over 400 areas that we could conduct research on that under their recommendations. But we had to prioritize one way or the other. So we came to the conclusion that we would focus on what we call in Canada alternative response measures. These are tools that would actually complement conventional mechanical measures that we use now for cleanup in Canada, which is primarily booming and skimming. And the 4 alternative response measures we focused on were the use of spill treating agents, Insitu burning, oil translocation, and decanting and oily waste disposal. Although these technologies are used by countries around the world, in many cases they can't be used in Canada right now due to a number of federal acts and policies. For instance, under the Fisheries Act, you can't put any deleterious substances in the marine environment. So therefore, legally, we can't use chemical oil dispersants for ship source spills. So the question is, what science we need to bring to the table to change policy and regulations and help us make decisions on what arms we can or cannot use. Another area of focus was identified as natural attenuation, because there are many cases, especially in Canada, due to logistical constraints, due to remote areas, as well as sea state conditions, for example, where we just can't use active countermeasures effectively. So we have to have a better understanding of what happens to that oil that's left in the environment for nature to clean up. And that's something we wanted to address with the public. And then addressing the other 400 things, there's core research that's common to all studies related to oil spill response. If you're looking at an oil spill and you're using techniques to clean up, where is the oil? So you can look at your strategies where you're going to apply the technologies. So oil detection, things like chemical analysis, look at weathering of oil, how it's changing, how it's impacting its latent behavior, which will obviously impact oil spill response strategies chosen. And then, of course, toxicity is a large area. Everybody wants to know what's the toxicity of whatever method you're going to use to respond to a spill. So, as I mentioned, spill treating agents are one of the things that we're looking at. And of course, the big thing that everybody wants to focus on now, or where the public's concern is that of chemical oil dispersants. So within the MPRI program, and I'll just give you a few examples of the programs that we have. It's impossible to go through all 40 of them, but under chemical oil dispersants, for instance, we have some programs that are looking at new product development. So looking at new formulations of chemical oil dispersants, for instance, looking at surfactants derived from fish waste. We're hoping that these products may be more effective and obviously safer to use than chemical products in terms of biological impacts. So there's a number of programs on that. Another area of concern is, well, if we're going to disperse the oil, where is that dispersed oil plume going? So we have a number of research programs under the MPRI program. For instance, at Memorial University and Dalhousie University, as well as CSRO in Australia. Looking at underwater vehicles, everything from large Explorer class submersibles for far field effects to small devices that you can handhold and launch from your arms. The other thing that we're looking at is developing AI technology so we can put these vehicles into the water column and they can go searching for the plume on their own. So there's a lot of developments in AUV technologies. In the Arctic, one of the concerns is that because of ice, there may not be enough mixing energy for dispersants to work well. So we have some projects looking at things like artificial energy by water flushing after dispersant treatment in calm seas or ice-infested waters. This is a project that's led by Sintef in Norway that's just been completed. As many of the partners mentioned today, one of the things that we're looking at in Canada is the conduct of field trials. So at the current time, we are actually asking for a permit to release oil for an experiment on chemical oil dispersant field trials. This would be an experiment that also has the engagement of NOAA, US EPA, US Coast Guard, as well as a number of collaborators from around the world. So we're hoping that we can get permitting to release oil on the east coast of Canada, off the coast of Newfoundland, sometime this summer or next summer at this time. We all know that when we're looking at modeling chemical oil dispersant behavior, one of the big challenges in the models is understanding oil droplet formation and behavior under water. So this is a program that's led by NJIT with Michelle Buffalo, as well as a number of people that are involved in the Gamma droplets program, looking at oil droplet behavior and modeling. So we're collaborating with these groups in the US quite heavily. And then another area that we're looking at in Canada is that for the use of chemical herding agents. And here's a photograph of some of the work that we've funded being conducted in the OMSET facility last summer, where Michelle Buffalo was doing some experiments. In situ burning is another area, and we already heard this morning from Bessie that we're collaborating together. We're looking at a number of experiments this summer or next summer in yet another field trial. We're asking for permitting to release oil off the coast of Newfoundland. And so this program is called the MPRI Offshore Burning Experiment, or MOBI. We're looking at testing a number of technologies offshore. One of the things that we want to understand is looking at various technologies. How can we better understand the operational window for in situ burning? How can we improve burn efficiency, reduce the impact from smoke, and obviously from the burn residue as well? So a number of technologies that we want to test in this field trial experiment with our collaborators in the US as well as Canada is looking at things like the flame refluxers that we've heard this morning to increase the burning efficiency. We're looking at the burning tongue technique, as was also illustrated this morning. So cut down on the use of fire retardant boom perhaps in the future. And we're also collaborating with ExxonMobil with Tim Nedwed, who's been, as many of you know, has been developing a remotely operated surface vehicle to apply herders and also to ignite oil slicks at sea after they've been herded. And then working with US EPA and NOAA and the US Coast Guard, I'm looking at testing the next generation of smart protocols for monitoring field studies, both in situ burn as well as chemical oil dispersants. Oil translocation is another area that we're looking at primarily right now at Shoreline Cleanup. And for this, we want to have a better understanding of what goes on when oil is entrained in shoreline intertidal sediments, have a better understanding of oil particle interactions and what drives the oil translocation and the movement of oil from shorelines into the water, and also looking at biodegradation for that oil that is translocated into water. So we're trying to understand all these processes. We have studies, as you can see in this image on the right-hand side, where we have a system of laboratory mesocosm experiments that we're conducting. And we're also developing a large-scale mesocosm test facility on the west coast of Canada and British Columbia at this time. And this project is led by Ed Owens, as well as the University, Concordia University in Montreal in Canada. Under the oil translocation project, as Robin mentioned, we've been working on surface washing agents in Canada. And besides looking at what's out there already and testing them to look at efficacy, we're also trying to develop new products. And for instance, as an example, there's a study that we've completed looking at the development of nanocellulose particles that we could use to enhance oil translocation from shorelines. So they're developing products and looking at toxicity that could be related to the use of such products. On the larger scale, for decision making on shoreline cleanup, we have a large program where we're trying to build essentially a decision-making tool for cleanup on shorelines. And so we've been sampling sediments around the coast of Canada, including the Arctic, putting all this in a database, along with physical chemical data, as you can see in the image there on the database. And then looking at building a model to help us make decisions on whether what options we use in terms of cleanup on shorelines, whether we use active strategies or not. And so this is under development right now. The model's in its test phase and it's ongoing. And we think that this will work quite well to help us make decisions on cleaning up oil shorelines. we can always improve on what's already out there. So one of the challenges in Canada, as I mentioned, is the fact that in Canada legally, we can't put any deleterious substances in the marine environment. So one of our challenges is that when we go out and we're running operations at sea and booming and skimming, everything that we bring back on deck from skimming is brought back to shore. And so obviously we can enhance the efficiency of operations from sea. If we can do the oil water separation at sea and put that water back into the ocean, even though it contains a small amount of oil. So we're trying to enhance the techniques for oil water separation or decanting at sea to reduce field storage on board ship and transport, and therefore increase its efficiency. So we have a number of projects working on separating oil and water. In terms of decanting, the University of Northern British Columbia is working on a nano and micro bubble gas flotation technology. This is something we're working on taking to the operational scale, and we hope to conduct a field trial on the west coast of Canada this year, where we will bring water at sea onto the Coast Guard ships, produce water equivalent to what would come back on board from skimming and booming, and then testing how effectively technique works. There's also a number of labs working on other technologies, which we hope to be able to scale up to an operational level use in the future. So for instance, in Memorial University in Newfoundland, they're looking at development of hydrophilic meshes and activated carbon methods of removing hydrocarbons from water. At the University of Toronto, they're looking at surface engineered sponge absorbents, where they can actually put the oil through these sponges, and these sponges are reusable. We're working with the CSRO in Australia. We have a very strong material sciences group, and developing other technologies, looking at porous organic polymers to do something similar to separate oil from water using these solid phase materials. In terms of natural attenuation, we want to understand what's the potential for the degradation of oil spilled in the Arctic, and of course, what's the baseline oil concentrations in the Arctic. So one of the projects we have is a natural attenuation project in Hudson Bay along shipping routes, and another one is in places like Cambridge and Resolute in Canada in the high Arctic, where we're looking at oil biodegradation potential for fuel oil spilled on beaches. Our concern in the Arctic is not spills from offshore oil and gas exploration. Our concern now is the movement of ships in the Canadian Arctic due to climate change and the larger open water season in the Arctic, as well as the transport of fuels to the Arctic to serve communities and industrial sites such as mines in the Canadian Arctic. We have a number of studies where we're putting in situ samplers and looking at different monitoring technologies, including eDNA technologies, on how we're trying to understand microbial degradation rates at sea. And so we're conducting these studies both on the Atlantic Ocean, Pacific Ocean, as well as the Arctic. The research is led primarily by the National Research Council of Canada in their biotechnology lab. And for the eDNA work, it's with CSRO in Australia, who've developed a system for doing automated eDNA sampling analysis. As I mentioned, we have a number of cross-cutting activities from oil detection, oil fate and behavior, toxicity, risk assessments. And we've coordinated these programs. So, for instance, the toxicity work is done by one lab for all of the MPRI programs, so we can compare results from one technology to another. Some of the studies in cross-cutting are characterization of low sulfur fuel oils, risk assessments, looking at models in the Canadian Arctic to try and understand hydrodynamic ice models, oil spill risk assessment, There's a study, for instance, or many studies that we have, but one in particular with NOAA and US EPA, I'm looking at oil slick thickness that we're conducting at the Olmsted facility. In California, many of you may have known Uda Paso. She's now moved to Canada, and we're funding some of her work looking at oil particle interactions because of all that interest in potentially oil sequestering onto marine snow. As I mentioned, toxicity studies looking at how clean is clean. But one of the concerns in Canada is, well, it's great to know about toxicity of a cod in Norway, but Canadians want to know what's the effect of oil or oil spill cleanup technologies on Canadian species. So we're doing a lot of tests on commercial species of interest in Canada, such as American lobster, cod, blue mussels, green sea urchin, Arctic ice algae. And we're not only testing chemical oil dispersants, but looking at the oil itself and things like herders and spill treating agents and surface washing agents. Putting everything together on the big picture, one of the things that we're trying to do is build whole of ecosystem models. So we're putting quite a bit of emphasis right now on building a model using the Atlantis model that's quite well known. I'm trying to build these whole ecosystem models, and we're building a model right now on the west coast of Canada for the Salish Sea. And so in this model, we're trying to predict if a spill occurs, where does the oil go? What are the impacts, not only on fisheries, but as other things of ecosystem services and everything else. And so these are large scale models that we're trying to put together. And what's the influence from the various strategies that we could use in oil spill response when we're looking at these whole of ecosystem models. So that's under development at this time. So overall, the focus of the program is, as I mentioned, how do we expand the toolbox for oil spill cleanup in Canada? And the idea of this whole program is to provide the science that we could use in decision making to improve oil spill response preparedness and our response regime. Obviously, we hope this project will lead to development and commercialization of products, and of course, acceptance in the application of response strategies. And by working with partners around the world, including everybody in the US, in academia and industry and within Canada, we feel that this leverage research is the way to go. It replaces or reduces duplication of effort between all of us and drives the science forward. And one of the most important things for this program to me is that under this program, we're educating what I consider highly qualified personnel in oil spill research to replace all those people that I consider like myself with either no hair or gray hairs. We're generating that new generation of young scientists. Thank you.
Yeah, thank you, Dr. Lee. I'm continually so impressed by the breadth and quality of work that the OPP MPRI group is doing around the world, and certainly second your zeal to continually be bringing in the best and the brightest young people coming in and taking us forward. Do we have any questions for Ken?
Yes, from Bill Adams. Does the MPRI have input data for Canadian coasts that could be used with the NOAA modeling tools that were discussed earlier, or will be discussed later? I apologize.
Yes, I mean, there's a lot of, you have to remember, there's not only the MPRI research program, which is just one program under the Oceans Protection Plan. So for instance, Environment Climate Change Canada has been surveying almost all the coasts around Canada and doing that work. And as I mentioned in the project where we have with Shoreline Cleanup, we're collecting data along the coast and obviously offshore too, and looking at natural attenuation and trying to understand potential biodegradation rates. So we'd be glad to share that data. And that's the whole idea of this program, is how do we network with people and try to drive the science forward.
That's terrific. Thank you, sir.